different angles. Okay. Okay, Doctor. I think I will start with the questions. And where I know you are the father of geosynthetic, as many will call. I'm just wondering, when did you first start your interest in the study of geosynthetics?
That was in 1969, 1970, 1969. In fact, I was designing a small dam, not so small, but 17-meter high, earth dam, and the first investigation showed that we were not going to have enough impervious soil. So I thought of using a plastic film, not called the geomembrane yet.
Mm-hmm.
So I started getting information of those materials. But then when we had the more investigation available, it turned out that we had enough impervious material. So I did not pursue this idea. However, it had put me in contact with manufacturers of plastic materials. Then during the dam construction, there was a crisis because we could not get the appropriate sand for the filter. And this was because it was a small dam, so the amount of sand was small. So the local quarry had a lot of work with big projects like roads, and he did not want to make the special sand for us. So very quickly I had to decide to use a non-woven fabric. We did not say geotextile at that time. Why did I have the idea? Because some tests had been made on unpaved roads and also embankment on soft soil the preceding couple of years in France. They were limited tests, they were not filters, but I was aware of those tests, so I got very quickly information of those tests. I did not get much information, and I decided to use the filter, the geotextile, the fabric filter, fabric. I was very lucky because it worked. After the fact, I have shown why it worked, but I was lucky. Not completely lucky because I knew that in the unpaved road and the embankment on soft soil, there was good separation provided by this geotextile, but there was no filtration per se. And it was the first use of a non-woven as a filter and a non-woven in a dam, and a geotextile in the dam.
Okay. The second question will be like, you were a professor for more than 10 years in a university in France, and you just leave the university. So what the reasons behind leaving the university and switching the academy to working in practice?
Well, that was because of geotextiles and geomembranes. Because from 1970 to 1978, when I left, I became very, very involved with geosynthetics, and I could not, it became more and more difficult to teach. So, because I was already traveling to the United States, to South Africa, to Australia for consulting work for these materials. Also, I had a lot of projects in France. I started doing some research, writing papers. So I was so busy, I had to make a decision. And so I decided to become a full-time consultant. And I got organized to do it in France, but before I decided to come to the US for 2 years So I took a leave from the university. I was allowed to take 2 years. And so then at the end of the 2 years, I received a letter from the president of the university, and I realized I had forgotten that I had to come back. So, so I was so interested, so I replied very briefly. I said, no, sorry, I'm not coming back.
Okay.
And so the reason in the United States is because I wanted to speak English.
Oh, I see.
Okay.
Yeah.
So the
But
next-
it turned out to be far more than that because of all the opportunities you have in America.
Yeah, I see.
Actually, when you moved from France to United States, what obvious difference did you find in terms of education and engineering practice between these two countries?
Interesting. The first shock, of course, is to use the English unit. And then the education I found was, well, I don't know the education well because I've not been teaching here, but I worked with, it was interesting because I worked with American engineers, of course, but I also worked with French interns, because in my company in Chicago there was Woodward Clyde Consultants, which is a very well-known consulting firm, which is now part of URS. There was a tradition of taking French interns in that company. So we had a number of French interns, and since I was French, I got them to work with me. That was quite interesting because they were more, I realized that the American engineers were more efficient. They were going by the book, the method that they learned at school, and they tried to solve the problem quickly. I saw that the French were not so interested in the official methodology, and they would try always to find new ways to solve a problem, which was not always very efficient for consulting practice. And in fact, I learned how to use both because we had some, especially with geosynthetics, we had some projects where we needed to be more innovative, some projects where we need to go by the rules. So having a team of American and French engineers sometimes was quite useful. But besides that, for me, it made no difference, absolutely no difference, no.
So the next question, you coined the terms geotextile and geomembrane. So how did you come with these terms? Because more than an engineer, I am a poet, and so I like to write, and I do engineering as a hobby, but and so I like to write. I like words, and so that's why I thought of those terms, and I was not so sure that it would be adopted, but I wrote a paper on terminology that was presented at the International Conference on Fabrics in Paris, which is now called the first international conference on geotextiles. And by the end of the conference, 2 or 3 days later, everybody was using the word geotextile, not the word geomembrane, but the conference was about fabrics. So, that was nice, but it's amazing because it contributed, I don't know if it started, but it contributed to the geoterminology and then many geo things, and of course including geo-legend came as a consequence.
All the geo stuff start from there? that time?
To a great, yes, yes, oh yes, yes,
Okay.
in geotechnical engineering, yes, 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 yes.
So where
Unfortunately.
where there another terminology used before using geotech?
Well, a reason I did that, of course, is because it was not only for poetry, it's because they were, the term filter fabric was used. And
Yeah.
that was obviously not correct because in many cases they were not used as filters. So, and it takes time to use the terminology, but not too much. I mean, it was adopted fairly quickly.
Okay, and the next question. So when did you started to have the idea of starting an international society about the geosynthetics?
I started in early 1982, and of course I remember exactly the circumstances. Why was I so driven by that? I'm not so sure, but I thought it had to be done. I had no long-term plans, but I thought it had to be done. So in March of '82, I heard that there was a symposium organized in Switzerland to talk about those fabrics. I established contact with them. I mean, they know me and I know them. So I decided to go to, I was in the US, I decided to go to Switzerland to present that proposal. And that was well accepted. Fortunately, there was, at this symposium, people from countries around Switzerland, like Germany, France, Italy, etc., England. And so they all liked the idea, much more than I thought. I thought that people would say, oh yes, it's good, but no, they were enthusiastic. So shortly after that, in June of '82, there was a meeting of ASTM, as usual, and fortunately it was in Canada. I say fortunately because so we had many Canadian people. It was not only US, it was a little more international. So at the meeting I asked to have some time to present the concept, and it was accepted. Okay, good. But in the meantime, I had been asked in 1980 by American colleagues to organize and chair an international conference on geotextile, which was very nice, by the way, because I was coming from overseas, but they did not ask an American, they asked me to do it. Yeah. And so I was in a good position after those two meetings, since I was chairing the International Conference on Geotextile in August of that year, to organize a big session to launch the society. And so the success was even bigger than I thought, because the room was more than packed, and I presented the concept, and everybody agreed, so that's how it started.
So
The good thing that was done, after that I wrote the bylaws of the society with somebody from Belgium who was the first secretary of the IGS, and he had a very good point. He said this society should have a significant participation from manufacturers. And I was not so prepared for that, because I was thinking of professional society with only professors, engineers, etc. People, individual working for manufacturers, but not corporate members. But he convinced me, and so we put that in the bylaws. And this has been essential to the success of the company. They were very supportive. The manufacturers were very supportive. And I remember a dinner I had with the president of ISSMFE, now it's called ISSMG, and he told me that he was very impressed by our success with corporate members. So apparently he said that ISSMG was not that successful with corporate members. Be careful with what we write. We don't want to criticize the other society, but I want to say that this was a key point which is a little unusual for us professors. I was a young consultant and a former professor. It was a little unusual, and it worked very well.
Okay, the next question, the geosynthetic has great role in geotechnical engineering. So the question will be, could you give us an example how geosynthetics prevent a major disaster in a project, or what is the most common misstep in geotechnical failures involving geosynthetics?
Well, these are two different things. I saw the question.
Yeah.
Yeah, because you say geosynthetic would prevent a big failure, and then you say example of failures with geosynthetics. Is this what you said? Yeah. No? Yeah. Because it's difficult to say how a geosynthetic could prevent a failure. So perhaps the best example is in unpaved roads, in fact, because and this was in fact the first success of geotextiles in solving a problem. Some woven geotextiles fabrics had been used in the US and also in Holland for filtration of bank protection, not inside the filter, but for bank protection. But in this type of application, success and failures are very difficult to evaluate, because this is an application where no matter what you do, you need maintenance. I mean, you cannot make a bank protection that will work forever. So with sand filters, geotextile filters, it's something that requires permanent maintenance. Whereas with unpaved roads, the result is very spectacular. I mean, you drive a truck in an access road and the truck is bogged down immediately, or it can work. It can run if you have a geotextile. So that was the first application where there was a real black and white success of geotextile. Yeah. And that happened at about the same time in '68. That was before I was involved in England and in France at the same time. Yeah. Now, there are certainly other projects where geosynthetics prevent failure, but that would be very difficult to elaborate on that. The failures with geosynthetics, there are many, and I think it has to do with lack of education, and this has been something disappointing, because there is a big gap between the knowledge of knowledgeable people and the knowledge of ordinary engineers, consulting engineers. And this will take 1 or 2 generations. So it will not be the case when you are in 10 or 15 years for you, when you are active in teaching or in consulting company, because I think at that time there will be education. So many of the mistakes I see are so easy to explain. They could have been prevented if people like G or myself had been involved in reviewing the project. Mm-hmm. So I think what we can tell people who are young, be educated with geosynthetics, and I don't know the situation in universities at this time. I don't know if there is enough
I mean,
education.
they try to push to include
Mm.
geosynthetics in the undergraduate education, but really it's very difficult.
Yeah.
Mm.
And at the same time, I would think it would be a big mistake to have people who graduate with only knowledge of geosynthetics and not a good knowledge of geotechnical engineering.
Mm.
That would be a big mistake, big mistake. Because when I was chairman of Geosyntech Consultants, I kept saying that I prefer hiring an engineer who knows nothing about geosynthetics but knows very well geotechnical engineering than an engineer who have been in a few universities where they have teaching and even research on geosynthetics, and they come with a knowledge of geotechnical engineering that's not so good. So we have to be very careful with that. Geotechnical engineering is very difficult, very, very difficult. A young engineer who comes and knows many things about geosynthetics and does not master pore pressure, that's a disaster. So we have to be careful with that.
I think one more question that they can stop.
Okay.
Well, yeah, so I say, for the young generation, be educated in geosynthetics, but be strong in geotechnical engineering. If not, you will make mistakes.
Okay.
And for the people who are in their 40s, 50s, go to conference, get more education, but sometimes they don't have enough time. Get your projects peer reviewed when you use geosynthetics. I have seen so many mistakes where they would have spent a few $1,000s asking a knowledgeable person review the project instead of having a lawsuit for $200,000-300,000. I've seen that very often.
Yeah, I think it's true. Dr. Han always advised us to be strong in mechanics.
Mechanic.
And
Yeah,
this-
yes.
this is the mechanic there.
Mechanics, geomechanics, geotechnical engineering. I totally agree. You cannot be good in geotechnical engineering if you don't, if you're not good in mechanics, if you don't understand all the concept with stress and strains, etc. Absolutely. And you cannot be good with geosynthetics if you don't have geotechnical engineering, and you need mechanics. Absolutely. Absolutely.
Well, Dr.
Last one.
Giroud,
Last one.
last.
No,
Yeah, I know.
no, but we go fast. So that's
Okay.
fine.
Okay.
Okay.
In 1987, you suggested that actually from geotextile to geosynthetic is a revolution in geotechnical engineering. Why did you think this change was so important, and how has this revolution changed the world?
Well, because there have been, in the 20th century, there have been many innovations in geotechnical engineering. But this is the first time there is an innovation that is applicable to absolutely all activities in geotechnical engineering. This is the first time. There have been great development with deep foundation, with slurry walls, etc. All of that was limited to deep foundations or underground work. But it had no impact on many other things, on filtration, on waterproofing dams, etc. Whereas you find, and you can review all developments in geotechnical engineering, they were very good, very innovative, but limited in scope. This is the first time we have not a vertical but horizontal development, innovation that affects all branches of geotechnical engineering. This is why it was a revolution. Yeah. Because you can do geotechnical engineering without slurry walls if you are not involved in the underground, or not underground, in the deep ground or the foundation, deep foundation. But you cannot do today geotechnical engineering with geosynthetics because they are applied in all branches of geotechnical engineering. And that may be, we're back to the preceding question, your question, I think, about failures. Because since it is involved in all branches, that people who are not educated in geotechnical engineering, they may be at a loss because they see those geosynthetics everywhere, so they feel they don't have the education, or which is good, by the way, because then they use consultants, but they may feel, oh, that's an easy tool, so I will use it and not pay too much attention. So, so that's these two things are linked. I think nobody would use a deep slurry wall without talking to experts in slurry walls, because if I had to do it, I would not know what to do, so I just know the principles, but I would need a specialized expert, specialized company, etc. With geosynthetics, there's a tendency to think that, well, they work everywhere, so that's easy, You want to, you need a waterproof barrier, just put a geomembrane, it's impermeable, so no problem. Except that it will not work if you use it casually. A geotextile, it has little holes, so it will be a good filter. Yeah.
Should they continue?
But
Shall we continue? Or?
yes, go ahead.
Okay, I think that brings me on to the next question. So there's so many different type of geosynthetic product on the market now. And then what is the best way to select a proper geosynthetic for the application? People
need to know the properties of the materials, and so there is a need for education on geosynthetic properties. But you see, the variety of soils is great also. So if you don't know how to measure the soil properties, you will make a mistake. I mean, if you ask somebody who has absolutely no education in geotechnical engineering, they don't see a difference between sand and clay. I mean, they see that on the ground. So then you need education to see the difference and to evaluate, to measure the difference. So essentially, I think we need a good education on properties of geosynthetics. That's the big thing, because we understand, it's fairly easy to understand the functions of geosynthetics, except that we have to be very careful because in a given applications, there may be several functions. G knows that very well. I mean, unpaved roads, you cannot say it's just reinforcement. In fact, it's not just reinforcement, it's more complicated than that. And if you have separation at the same time, and do you have 20% separation, 80% reinforcement, or other function more subtle, So we have to recognize that there may be more than one function. Sometimes it's just a filter, that is one function. So you have to be careful. But this is relatively easy to understand. Properties are much more difficult, the stress-strain curve of geomembranes, some of them are very tricky, and I know it explains many failures, and I know it is not well known.
Actually, many design methods have been developed by researchers and engineers, but only a small amount have been adopted in the practice. However, you have developed a number of design methods, and most of them have been used to solve many practical problems. What is the most important factor for your methods to be well adopted in the practice?
Interesting question. Yeah. It is true that many design methods have been developed and not used, including by me. But I have seen these problems in some publications, and I think it has to, it's some of the methods that are published and not used sometimes are good, but they are not presented in a way that is simple to use, and that's probably because the authors of the method do not spend enough time working in a practical project. That's a big problem. And you don't have this problem with G, because he knows the real world, and not with me, because I've spent a lot of time in the field. I've spent a lot of time designing. I've seen how things are constructed. I saw the mistakes that are made in construction, etc. So it very often depends on the mental preparation and mental attitude of the authors of the method. It may be good mathematically, but it is not presented in a practical way, simply because the authors do not know what are the practical things, do not know the practical life. During my stay, my 15, 16 years in a university, researching and teaching, I have seen a number of bright people doing good things, leading nowhere. And that was very frustrating to me. So it's important to be practical, to present things in a simple way. I always wanted to solve problems simply because I have problems. Because when I design, sometimes I don't know what to do. I hesitate. I say, oh, maybe I need to develop a design method. And another important point is many of my papers, many were started in actual projects. I had the problem. I had to find a solution. And sometimes I found a solution and it gives me an idea for another further research. But I went beyond. But so in my work there was always interaction between practice, including field practice and mathematics, always.
So the next question will be like, what are the most important qualifications a consultant engineer should have?
The consulting engineer should be innovative, should be rational, should not believe in anything magic or miraculous. I have seen consulting engineers who some were totally against geosynthetics because it's new, they have not learned that at school, so they won't use that. Well, but these people will be working for another 20 years, but this is ridiculous to stay 20 years out of innovation. That's one category. I've seen another category, those who believe that, oh yes, that works very well, that should be easy, and they are ready to accept whatever is told by the manufacturer or the supplier. For example, I've seen people believing that the geomembrane is perfectly impermeable, so they just need to put it, and there will be no problem. But some people have done that on soil that has a high degree of solubility, and I've seen that in Iran. The Esfahan canals are on soil containing, sorry, containing a lot of gypsum.
Yeah.
I've seen the same thing in Syria. I've seen a project in Jordan where phosphoric acid was stored in a geomembrane-lined reservoir on top of limestone. A little hole in the geomembrane like this became a hole like that, where everything burst, and it took only a few months for that. So, and when I was asked to come, the people said, but we were told by the supplier of the geomembrane that it was absolutely impervious, and in fact we have a contract that says the geomembrane is guaranteed totally impermeable. I said that an engineer should always plan for the potential failure. You don't want an entire project to fail only because a bird falls on the liner and makes a little hole that will cause a cavity 2 meters in diameter, and 2 meters deep, and everything collapses. So engineers, consulting engineers, should not be should have an open mind. On one hand, they should be open to new products, but on the other hand, they should not believe everything. So they should be highly critical. And even if they don't have, it's easier to be critical if you have the education about geosynthetics, but if they don't, they should be prepared to ask advice from knowledgeable people. If not, they will make big and sometimes stupid mistakes.
I see.
And people should be absolutely rational. Should read a paper I wrote on, I will send it to you, on failures. If you predict a failure using a rational analysis, even though the failure never happened before, it is likely to happen. That doesn't mean it will happen for sure, because there are factors of safety, but it is likely to happen. And if it does happen, any knowledgeable person will explain that you are wrong, because you have a rational explanation of a failure, you don't believe it, you keep constructing, designing, even though there is a rational explanation. And this happens quite often. And it has happened to me several times. Fortunately, I didn't make the mistake, but when I was a professor designing foundations, I was in a case where we were designing a foundation in a place, and there were buildings all around, all on shallow foundations. And I look at the field data and I say we cannot build on shallow foundation, or we have to do some special work, or we will use pipe, but we cannot build on strips. We will have to have a complete raft. But it's cost a lot of money, you cannot do that. Every building around is building on strip foundations, and they are still around. I say yes. So I fire me. I mean, I was a consultant. I say, okay, don't even pay me. I am out of the project. Do what you want, but you will not get my approval. But yes, you can. You are knowledgeable, etc. I said, this is because I'm knowledgeable that I say no, because I do not guarantee that it will fail. But if it fails, everybody will, no, not everybody, but some experts in the case, there will be a litigation, will say, look, this professor teaches geotechnical engineering, he says we need to do it that way, he has all the data, he concludes that it will not work, and he says it will work. So, so when you have a rational explanation, you should believe it. Geotechnical engineering works. the theories that we use are good. If the theories that we use show that something is not going to work, it is likely not to work. And even if there are factors of safety, etc., it may not work. It may work, but if it doesn't work, you will look very stupid, and you will be liable.
Mm.
So engineers should believe what they do. Yeah. I predicted the first double liner that was two geomembranes and a geonet in between. It was in 1980. It was a very special case. It was an underground reservoir, and unfortunately the reservoir was given, it was a square, right angle. I said it should have been rounded or round corners. And my design showed that the geomembrane will burst in the corner. Why? Because it was HDP. HDP has a tricky stress-strain curve. But in the lab it fails at 700% strain. So at that time there was not much experience with HDP. And especially for me, it was my first project. But looking at the stress-strain curve, I said it will fail. The manufacturer from Germany, at that time it was imported from Germany, because in Germany they had several years of experience with HDP. Manufacturer said, this type of failure never happened. Our product fails at 700% strain, and so it will not happen. I told the client, this type of elongation is such that it will not fail like in a tensile test. It will fail because of yield, and that yield will happen when you have sufficient strain. It was about 15% just at one point, and then it will yield and burst. No, this has never happened. I said, yes, this has never happened. So the client says, well, it has never happened, so therefore we don't follow your advice. I said, fine. Fortunately, I had done everything in writing. I still have the report. It failed at the first filling of the reservoir. So I presented that at the International Conference on Geomembrane in 1984. The representative of what has become GSE now, they wanted to kill me in the lobby because they said you are going to destroy the industry by telling everybody that geomembrane can fail at 12% and not 700%. And I just replied to them. They were absolutely furious. I told them, one day you will tell me that I am doing you a great service, because if not, you will have many, many failures of that kind. Yeah. And of course, within a short time, designing for yield and not for tensile failure became the norm, as you probably know, for geomembranes with yield. So if you can explain a failure, believe it.
Okay, I think that comes on to another part. I think in one of your lectures you mentioned the rational analysis and good observation is the crucial tool to solve any engineering problems. So how to make a good observation and how to develop a skill in making good observations.
That is, this is fundamental in engineering, not only for geosynthetics. We need to make good observation because, of course, we cannot imagine everything. So all science is based on good observation. But sometimes you make good observations because you have some knowledge before. if you just see things, there are plenty of things happening in this room and we don't see them because you are not expert in painting, you're not expert in other things that happen here, in light transmission, and there are things that happen. So in order to make good observation, you need to be knowledgeable. But that's not enough. You need to be knowledgeable and prepared to change your mind. To give you an example, it is well known that some geomembranes have wrinkles because of thermal expansion on a sunny day. So people go to the field and they look at, in particular, high-density polyethylene geomembrane. They look at them and they come back and they say, oh, we have seen many wrinkles. They see another geomembrane like PVC geomembrane. Oh no, we did not see many wrinkles. Well, there are different geomembranes and different behavior. Okay, this is what they see. That's the observation. Then I write a paper on the theory of wrinkle development. I demonstrate that wrinkle development depends not only on thermal expansion, you need thermal expansion, but it depends on the stiffness of the geomembrane, and it depends on the friction between the geomembrane and the underlying soil. There's 3 parameters, not 1. So you take 2 geomembranes with the same coefficient of thermal expansion, and one has a high friction, one has a low friction with the ground, like a textured geomembrane or a smooth geomembrane. The theory I published predicts that with the smooth geomembrane, you will have high wrinkles, but you will have less. Of course, if they are high, there will be less for the same expansion. If you have high friction, you will have more wrinkles, but they will be smaller. Yeah? That's exactly the opposite of what people report that they say. Yeah? Now, at Queen's University, they used a balloon, or they would use a drone to take pictures of textured, and they found exactly what and smooth geometry, found exactly what the theory predicts. More wrinkles, and then they measured them, smaller wrinkles. So, but people, they see, when they see big wrinkles, they report many wrinkles. They don't say many, they say few, but big. They report many. And that's very typical. So, to do good observation, you either need to be very precise, you should not say many when it is high, and you should be, or you should be knowledgeable, preferably both. Because when you are knowledgeable, you are more alert, and you say, oh, be careful, I'm going to check. This is what happened to the people at Queen's University. Mm-hmm. They had the theory, they wanted to check, and it worked. And they told me it works. And same thing with the stiffness of the geomembrane. If the geomembrane is stiff, the wrinkle is very strong, so it needs high friction to counteract the bending strength, the bending moment. To have a high friction with a given geomembrane, you need a long length. So the distance between wrinkles is very high, it's very large. So if you have a stiff geomembrane, like HDPE, you have fewer wrinkles. Again, same thing, and they are high. So if you combine all the parameters, friction and stiffness, you find that HDPE geomembranes have few wrinkles, but they are high. And now people say, oh, PVC, I see no wrinkles. Well, the theory shows that there are many, but they are very small, so you don't pay attention to them. So people say, oh, I don't like to have many wrinkles. Wrong. They don't think right. What is right is I don't like high wrinkles, because the high wrinkles, of course, if you push gravel on them, you damage the geomembrane. If you have gravel and you have a bulldozer on top, you can
Yes.
distorted, etc., etc., etc. So it's very important to be rational, not to say many when it's few, not to say to look at one parameter, thermal expansion, when you have three key parameters, perhaps others, but three main parameters. So being rational is essential.
Well, Dr. Giroud, consulting engineers typically do not publish papers, while you have actually published more than 400 high-quality technical papers at your extremely busy schedule. Actually, why do you like to publish papers, and how can you be so productive?
Again, because I'm a poet, so I like to write. And, I like to communicate, I like to explain, so that's a personal preference. Also because in many cases on actual projects I had to solve difficult problems, and then I wanted to share. I think it's then it becomes a moral consideration, but I think I have a certain talent or gift or whatever, as you all have, and so when we have a gift we have to share, whichever is the gift. So you cannot keep it for yourself, and so my capability is to understand engineering problems, we all do that, to solve them in many cases, we all do that, and then when I have an original solution, I feel the urge for sharing that. I don't think it's right for me to keep that. So it's a moral consideration essentially, and just the pleasure of writing. Yeah.
Two more questions, right?
Yeah, so you have been very efficient. I was afraid because I thought it could last 3 hours.
Yes, I mean, the next, just for last one, if you look back, what are the most important steps you took to make you so successful? Or do you have any advice for us to be successful in our graduate study and future career?
Well, work hard. Work hard. No, we are all successful in different ways. So just work hard, do what you like to do, and of course, if you want to succeed being an engineer, you have to solve problems. You have to in order to solve problems, you have to be open. You have to be rational. You have to believe what you do. You will be criticized by people who will tell you this problem is simple. It has been solved already. Why do you do what you do? Well, if you think you have a better way of doing things, or if you think that what is being done is not totally safe or not optimum, you want to do it better. And if you have a good reason, a good rational, good demonstration, then you will be successful. You need to be open to learn all the time, and then you need to be rational to clearly to solve problems, to explain to others. When we hired new engineers at the Geosyntec Consultants, when a new engineer was hired, in many cases I was not involved at all, so then the final step, he would come to my office, and I remember one day when engineer came, and he was a little shy, but he had been selected, so he was obviously good. He comes to my office and talked to him for a few minutes, and I told him, you know, I am always right. So he was shocked that I say I am always right, and he did not know what to reply, and he finally replied, well, it's normal, you are the boss, you are the chairman of the company. And I said, no, that's not the reason I'm always right. I told him I'm always right because if somebody has a better idea, I change my mind and I adopt the idea. So he replied, I feel better. This makes life much easier for me, he says. I said, no, it makes life more difficult for you. He said, why? He said, I like what you said. He said, no, it makes it very difficult because you will be in a meeting with me and other people. You have an idea, you think it's better than mine, and you think I will change my mind immediately. No, you have to explain your idea. You have to be rational. You have to be, first you have to be brave. You have to talk, you have to explain clearly. You don't have much time. We are in a meeting. There are other people around. We are not stupid. Our ideas are not bad. If yours is better, I am prepared to adopt it, but I have to be convinced. I said, it makes life more difficult to you. If I were the big boss, always right and not listening to you, that would be very easy. So I said, okay, I understand. I said, yes, but now you have to work hard to be able to present your ideas, to convince others. And of course, others have a duty to listen to you and to adopt your ideas when they are good, when they are better. Mm-hmm. So what was the question? I don't remember what was the question. Why did I say all of that?
It's like, what was the most important step you took to make you successful?
Okay. You need to work hard for sure. You need to be open, have an open mind, and to listen, to be able to change your mind if there are better ideas. That's very important. But not to change easily. You have to be convinced. It has to be really better, because if you take the last idea that comes and it's the bad one, you should not do that. So you have to be critical. But being rational is essential. And G is very good at that, and when we prepare a course together, I said, JP, what you write is not perfectly logical. Okay.
Okay, so we have the last question. Dr. Giroud, you have seen the development of the geosynthetic in the past 40 years. Now, what do you see in the future of the discipline of geosynthetic in the, say, next 50 years?
Ooh. I am very good at predicting the past. But you know that's a typical exercise in geotechnical engineering. We are trained at predicting the past. You know, you're given a problem and say, we observed this type of failure. Can you explain it? Yes or no? Or this project was constructed. Did it fail or not? Can you predict that? So predicting the past is already very difficult, as you know. Many of those tests leads to failure of not of the project, but failure of the person trying to do the prediction. So predicting the future is more difficult than predicting. Perhaps not. Perhaps it's easier to predict the future than the past, because after all, you won't be there to suffer if it's wrong. So, I think I hope and I'm sure there will be better education. And, of course, and there is better education. So there will be development just by education, because they will be used much better. And so many of the stupid failures that occur today will not occur. But I think the next big development is probably biogeotechnology, I don't know the proper term, because the only limitation of geosynthetics is that they have to be placed as you construct. Now, I dream of a bio stuff that will be trained, educated, convinced to go into the ground where you need reinforcement, you know?
Yeah.
And this will happen. It's certainly a dream at this time, but this will happen. And there are already people who do some interesting work with bacteria, etc. I should not say more because I'm not knowledgeable in that, but that do start doing interesting things. And the big advantage, I worked on a project with people, but I gave up because I was not contributing. The project was to, in the Middle East, in Qatar, to stabilize big sand dunes. Sand dunes move and they cross, they cross a highway. One day they're on the right and 6 months later they're on the left. And in the meantime, they're on the right. So to stabilize the dikes, the dunes, that's geosynthetics can do nothing because we construct with the geosynthetics. So they try to use some microbes and the only reason I was involved is because they needed geosynthetics to store the microbes. You could put a cover on the dunes with some geosynthetic, geotextiles, or geomats, and some way of feeding the bacteria, etc. And then the bacteria will go inside the dune. So this is the extent of my knowledge. But I'm sure there will be fantastic development. It's a dream at this time.
Is there possible there's a live geosynthetics? Just like a bacteria, maybe it's still geosynthetics?
Yes, or no,
grow by itself?
No, but I dream of geosynthetics that would be generated inside the ground.
Mm-hmm. Yeah.
If you need a filter inside the ground and you say, I send a filter inside the ground, by it may take 6 months to develop, etc. But that may be a way to fix dams that need repair. There are thousands of dams that need to be repaired, that are becoming unsafe. And sometimes because of construction mistakes, no good filters, etc. Can you imagine? Well, today, the only thing we can do, we excavate a little bit of the dam, we put the filter, and we put a lot of material on top, or we do not excavate at all, and we put a geosynthetics, a drain filter, etc., and put a lot of earth on top, very expensive. Let's imagine you could send the filter inside.
So there's a possibility maybe integrate bio with geosynthetic together. I don't know, like artificial skin or this kind of thing, that maybe it can grow by itself.
Yeah. Okay. Well, thank you. You were very well organized. Thank you.
Thank you very much.
I have so many things.
Thank you very much.
Before I
Really
go.
appreciate it.
So, how do we go from there? You are going to write it and
organize. And I told them that they will send you for the review.
you send me.
Yeah.
I've been asked to do this for at least 3 years. So I started the file, I don't think I have anything in my computer. I collected some GeoLegends interview. I don't know where they are, but they are somewhere.
Yeah, but they also saw one interview somebody did in France and translated into English. Do you know that one? You probably know it several years ago.
An interview I gave in French.
Yeah, with somebody, maybe also a student or something. Then I think somebody translated into English.
Yeah, when was it? 2-3 years ago, or very
Do you
old?
remember when? Jim Witham shared with us.
Who?
Jim Witham with the Colony. James.
Yeah.
Yeah, he shared that interview with
Because I
us.
have a 2-page interview. in
Yeah,
France.
yeah, that one.
Yeah.
Somebody
With
translated.
a big photo on me, or no? Or
Is that
maybe you got on it.
I think the one we had is the English translation, so we don't
Yeah,
have.
somebody
the full-
translated.
Oh, okay.
Yeah, there was some question they didn't ask because we overlap with some over there.
Hmm.
But they tried to avoid the same question.
Oh, no, no, no.
Yeah.
Yeah, this is-
Yeah. Okay.
No, so thank you. You were very efficient. Yeah.
Thank you very much.
Okay.
Really appreciate it.
Yeah.
Learn a lot. I learned a lot
Is
too.
there anything you want? No, because I am starting, I have things I want to keep, if only for some time, because I'm still scanning from conferences. But I have a complete collection of international conferences from the very beginning.
Yeah, some of conferences I have too.
Hmm?
I have those conferences.
I have.
I may not have the early one, but. Okay, I think, I mean, because of time, I think, I don't,
Yeah.
we don't want to take up, more
In
time.
fact, Ed Kavazanjian wants some landfill conferences. You're not interested in
Yeah,
that.
I haven't done that
And
yet.
so I may give him all of those.
Yeah, yeah.
And what else? Yes, what else is, whatever I don't give now, I give 10,000
10,000,
to take
yeah.
everything. So
Oh, they wanted everything?
they said they want everything.
Oh,
so-
really? Okay.
But I don't know how they will get everything. But
Yeah.
I will.
They may come.
I have some at the end. I will.
Yeah.
Okay.
I tested that